Okay, so in this video we will talk about synthesizing, and it's just another example of how to synthesize. Well, I start with a secondary alcohol and I'm getting a secondary alcohol as well. However, this is a 2-propanol and this is the 2-butanol. So if we check the number of carbons, we have here 1, 2, 3 carbons, 1, 2, 3, 4 carbons. So this gives us a hint that during my whole process, my synthesis, I needed to use one of the chemistries I learned till now, and that will make carbon-carbon bond connections. So we learned that good carbon-carbon bond connections would be some sort of organometallic compounds like greener reagent will do the carbon-carbon bond connection. So when you're predicting, when you're doing the retrosynthetic analysis for this particular molecule, I would say, well, check initially what would give you one of the reactions need to show up where you have carbon-carbon bond connections. So I also want to emphasize that even though this is a 352 course, and we still gonna need to use a lot of 351 reactions. There is more than one way to synthesize from this secondary alcohol to this secondary alcohol there, from this 2-propanol to this 2-butanol. I want to show one of the ways, so if you wanted, you can pause the video and you can just do it by yourself and then check how I will think through the process. So first of all, we do the retrosynthetic analysis for this particular molecule, and then I will do the forward reaction. So if I'm thinking about on first carbon-carbon bond connection, I would say, well, I can break it on here and I can make this compound from a aldehyde. This is a secondary alcohol, so I know that an aldehyde plus a greener reagent, okay? So the thing now is, how can I make this particular aldehyde? Well, if I remember from chapter 15, that aldehyde can come from this primary alcohol. I can oxidize on this primary alcohol into that aldehyde. This primary alcohol can come from a double bond, and this double bond can come from my secondary alcohol. Okay? So now that I have thinking retrosynthetic backwards and I know how to synthesize it, I will make the forward synthesis to show all the steps and all the required reagents in order to have this final product being produced. So I know my secondary alcohol, the first step is making that double bond. If I remember from 351, and I will call here chapter 5, okay? From chapter 5, I learned that I can make an alkene from an alcohol using concentrated sulfuric acid, okay? Concentrated sulfuric acid will dehydrate, meaning it will remove a whole molecule of water. So I say here in this reaction, I have a whole molecule of water leaving and making the double bond. Okay, this is a SN1 chemistry. So we have the formation of a carbocation in that particular secondary carbon. And via this process, I can make my first reaction here. Now, I look my next one and I say, well, I need to make the this primary alcohol. If I have an alkene and I want to make this primary alcohol, I learned one reaction. It's called hydroboration oxidation, where I have my OH being added anti-Markovnikov. If I'm talking more about this specific reaction, I found it in chapter 6. It's addition of OH, and I know that is a syn addition, meaning my H and my OH is going to be added from the top or from the bottom side. I need a peroxide, so it'll be added anti-Markovnikov. And what else? Yeah, this is a reaction from chapter 6 as we talked earlier. Okay, so if you remember 351, chapter 5, 351, chapter 5, or chapter 6. Now, I'm like, okay, from my primary alcohol, I need to make my aldehyde. Now I start getting into really 352 chemistry on where I can oxidize my primary alcohol into a into an aldehyde. So I can oxidize my primary alcohol into my primary alcohol into my aldehyde, and I learned in chapter 15 about that, because in chapter 15 we talked about how we can do this chemistry, and I know that PCC or PDC would do that job. If I'm using PCC, I can say PCC and CH2Cl2 would be my reagent for that particular reaction. And yeah, I saw that in chapter 15. So now I'm thinking about, well, I need a greener reagent. I would just add my greener reagent here. And as I remember, my greener reagent will work as a nucleophile, do the attack here, and this reaction will end up adding a carbon-carbon bond here, a disconnection, and I need 2 steps in order to make my secondary alcohol. The first step, I'm going to use diethyl ether. I do not want to use water at all because I know that water will mess it up with my reaction. And if I want to make the yields even better, I need to use anhydrous diethyl ether as my first step. Once I have my intermediate, I can use the step 2, that would be an acid. So the acid will protonate it back. We'll protonate it, or we're going to have a proton transfer to this particular molecule. Just as a review, when we do that chemistry, I have here my greener reagent, TAC, making this 1, 2, 3, 4 on intermediate. Okay, so now I use the acid to proton transfer and make my desired alcohol. So I learned this chemistry in chapter 14. Okay, about greener reagents and everything else. So what I wanted to emphasize with the synthesis is that we do not have only one step. I could show you another way to do the same thing, to get the final product. But I chose this one because we have less steps, and the yields are going to be pretty good, pretty decent. And also because using this particular approach to synthesize the secondary alcohol here, we're going to use chemistry from chapter 5, chemistry from chapter 6, chemistry from chapter 15 and 14. Therefore, what I want to say is that even though we are in a 352 course, we still need to remember on chemistries from 351. So if at that point you're like, I don't remember what we talk about in chapter 5, or I don't remember what we talk about in chapter 6, I would say go back and review, because this initial steps here will show up over and over and over when you're doing synthesis.